Welcome to Homework Lib.
This is chapter 35, problem number 20. We're given the intensity at the central maximum as I naught, and we're asked to calculate the distance on the screen from the central maximum to the first minimum. So where the first minimum is located, as you know, is given by this equation. However, we're not given any information on the angle. So let's first calculate that angle. So d sine theta, since this is a minimum, m plus 1/2 lambda is our equation. We can basically get theta out of this equation. So then if you divide both sides by d, these are canceled. Sine theta is going to be equal to m plus 1/2 lambda over d. Then if you want to calculate what this theta is, then it's going to be inverse m plus 1/2 times lambda over d. So then theta in this equation is going to be in radians. Sine of, since it's a minimum, the first minimum, and m is going to be equal to 0. So this is 1/2 lambda over d is what we have. Then inverse of sine. Lambda is 660 times 10 to the power of -9 meters divided by 2 times the distance between the slits, 2.6 millimeters, though, so 10 to the power of -3 meters here. Now, from here, the angle is going to be 1.27 times 10 to the power of -3 radians. Now, in order to calculate where the first minimum is located, then we're going to plug it in here. Y is going to be 0.9 meters times tangent of 1.27 times 10 to the power of -3 radians, though. So then from here, it's going to be where the first minimum is located from the central maximum is 1.143 times 10 to the power of -3 meters. Now, in part B, we're asked to calculate the distance from, again, the central max to the point where we have the intensity I naught over 2. So now we have to remember the equation that gives us the intensity as a function of position on the screen. That equation would be I equals I naught cosine square in radians again, pi dy over lambda times r. So then we want this to be equal to I naught over 2, right? So I naughts are going to cancel. So what we have here, cosine square pi dy lambda r equals to 1 over 2. If we take the square root of both sides, then cosine of pi dy lambda r has to be equal to 1 over square root of 2. Now, if we want to go to where it's located, we're trying to get to y, right? So then how we're going to isolate this is that cosine inverse of 1 over square root of 2 then is going to give us pi dy over lambda times r. So then if we multiply both sides by lambda times r and divide both sides by pi d, do the same for both sides, of course, pi d. Then these are going to cancel out. We have y isolated. It's going to be equal to lambda times r divided by pi times d times cosine inverse of 1 over square root of 2. Now lambda is 660 times 10 to the power of -9 meters. R is 0.9 meters divided by 3.14 times 0.26 millimeters. So let's convert that to meters while we're at it. Cosine inverse of 1 over square root of 2. When we do this algebra, we're going to find the where it's located to be 0.57 times 10 to the power of -3 meters.